So welcome back. I'm Amit, the senior maths faculty at Nandyal Public School. And as per we promised, today we came with our first lecture in the series of solution of Gilbert's Strang book. And today we are starting to solve 1.3 exercise, which is based on Gauss elimination. I hope first two exercise is sort of very easy one and solution is available on some channel. I hope you will not face the issue. Today, if the time allow, I will come later on first to exercise also. But today, I want to start with Gauss elimination. And I will start to solve one by one all question. And today, my motive is to solve just first 9 questions, which is based on somewhere 2 cross 2 matrix. It's based on 2 cross 2 matrix, right? And these are the 9 questions which I'm planning to solve. But before coming to this solution part, it's very much urgent that you will cover up the first 2 lectures of Gilbert's tank. Yeah, if you will cover up, if you are already listened the first 2 lectures, then you need to start to attempt the question by your own. And if you failed anywhere, you can come and you can just check it out. Okay, so I will not discuss in much detail, but Gauss elimination is just a powerful method. Every machine, every computer, every software is using this method to solve the system of equation. If I have a system of equation, the Gauss discover a very beautiful method to solve that. And this method is working at most of the time. And now we are coming on that method. And let's start. I will come on first question without further explanation. Let me share my screen. Okay, so let's come on the question number 1. In the question number 1, they are giving two equations to you. The first equation is 2x plus 3y is 1, and second equation is 10x plus 9y is 11. And what they are asking for, what multiple of equation 1 should be subtract from equation 2? Yeah, so if I will write down the matrix form of this equation, so there are 2 cross 2 matrix, the 2 cross 2 coefficient matrix. You can assume here the 2, 10, 3 and 9. This is a 2 cross 2 matrix you can represent, which has all information. And what they are asking for, what multiple of the equation number 1 should I subtract from equation 2? What multiple should I take from here so that I can knock out this 10? What should I multiply here so that I can knock out this 10? What should I subtract? What should I multiply here so that if I will subtract it from 10, the 10 will become 0. What should I do? 5, right? So I can say that this is my first matrix. Now I am going to take the 5 times of first matrix and I am going to subtract it. So the first row will remain same, and if I will take the 5 times of first row and going to subtract it, it will become 0 here, right? And what it will become? 5 times of this element is 15 and 9 minus 15 is minus 6. So I think the 5 times of first matrix, first 5 times of first row, I'm going to subtract it and it will become 0. So 5 is the what multiple of L? So I can say L would be 5, right? And now it's a upper triangular matrix, which the Gauss want to do in every case, but that's all. The first step is done. Now what they're asking for after this elimination step, write down the upper triangular system. This is my upper triangular system. Circle the both pivots. So I think the 2 is my first pivot and minus 6 is the second pivot. You need to circle them, and that's all the thing. The 111 has no influence on the pivot. So that's all. My pivots are 2 and minus 6. That's all. These are my pivots. Alright? That's all. That's all. The first question. A very easy question. If you know about the determinant, I can say what will be the determinant of this matrix? Minus 12. You know that if you listen the second lecture, the determinant is just the multiplications of pivots. So it would be minus 12. If they are not asking, but if anyone is interested in determinant, it would be just minus 12. The number is associated with this 2 cross 2 matrix is minus 12. Is it okay? That's all. Now, can I come on second question? The first question is very clear. Now let's come on second question. Okay, in the second question, solve the triangular system of problem 1. They're same in a problem 1 they're asking for by back substitution. Okay, so let me write on my problem 1 again. My problem 1, the coefficient matrix was 2, 10, 3 and 9. So if I will write down 2, 10, 3 and 9, and now they're asking for to solve that and to find the value of x. And what was my right hand side? 1 and 11. So this is the argumented matrix which represent the last system of equation. And if I want to write down like that, you can. Okay, and now I choose the multiplier 5 and I kick out this 10. Right? I multiply the first row by 5 and subtract them. It becomes 0 here. And if you remember, it becomes 9 minus 15. It becomes minus 6. It's a 1. What will come here? I am doing 5 times of row 1. So 11 minus 5, it will become 6 here. Right? That is the final upper triangular matrix I got. So now can you write down the system of equation again for this matrix? It would be minus 6y is 6. And if you will follow up this, the first row, it is 2x plus 3y is 1. Okay, so if you will see this first equation, you can directly tell me the value of y. The value of y would be minus 1. And if you will see the second equation, 2x plus 3y is 1. You already know now y is minus 1. If you will put y minus 1 here, it will become 2x minus 3 is 1. You can say 2x is 4. X should be 2. So I think that is my answer. Y should be minus 1 and x should be 2. That's all. So if you will see this system of equation, which is you can see in the first question, I can say the solution of this system of two equation. And what's the solution? The x should be 2 and y should be minus 1. That's the solution. X value should be 2, y value should be minus 1. That's all. Yeah. If you want to just verify it, you can. If you will put x2 here, y minus 1 here, 2 times of 2, 4, 4 minus 3 is 1. That's first equation satisfied. If you will put 2 and minus 1 here, that may also be satisfied. 10 times of 2 is 20, 20 minus 9 is 11. That's also satisfied. That's the answer. Is it okay? I think my second question also done, right? Till here. Okay, now what they're asking further, if the right hand side change to 444, then what would be the new solution? They are saying their entire equation is same, but if they will change my right hand side from 111 to 444, then what would be my new equation? That's the question. So if they are going to change the right hand side, I think my argumented matrix will change. They are not changing the coefficient. The coefficient is still same, 2, 3 and 10, 9. 2, 3, 10 and 9. But they are changing the right hand side. And what's the new right hand side? The new right hand side is 4 and 44. And they're asking for what would be the new solution, which is I think again much easy. Okay, so again my first step would be I want to knock out this 10. For that I choose the multiplier 5. It becomes 0. It becomes 9 minus 15. It will become minus 6. This will change now. And what will be this number? 5 times of 4, 20. 20 I'm going to subtract from here. So it will become 44 minus 20. And it will become 44 minus 20, I think 24. Right? That should be my new matrix. And now what the system it's represent? If you will write down in terms of equation, it represent 2x plus 3y is 4 and minus 6y is 24. If you will see this equation, you can directly tell me the value of y. The value of y would be 3. And if you will put value of y would be 3, what is x going to be happen? If y would be 3, 3, 3, 9. And if you will shift 9 that side, 4 minus 9, it would be minus 5. Can I say x would be minus 5 by 2? Please check my calculation. If everything is correct, x should be minus 5 by 2. 4 minus 9 minus 5 minus 5 by 2. That's all. Is it okay? So that's what. If you will going to change the right hand side to 444, my solution will change. Yeah, that's all. And that's obvious actually, because if you will assume that, if you remember the column picture, then you know that if I will write down this thing in a column picture, you know what does it means. I want to combine my first vector is 210, my second vector is 39, and I want to combine these two vectors in a right amount so that I will reach at 111. And what is the right combination here? I will take 210, I will go on this vector two times, and then I will go on my second vector one side down, then I will reach on 111. But if I will change this point 111, if I will change my destination, then obviously my combination will change, and that's change. If I will change 111 to 444 to 444, then my combination will change into minus 5 by 2 and 3. That's okay. Is it? My second question also completed, right? Okay. Now let's come on third question. Okay. Now let's come on the question number third. And in question number third, they are saying what multiple of equation 2 should be subtracted from equation 3. Oh, there is no equation 3. So yeah, just change it. What multiple of equation 2, or is it do it with equation 1, should be subtracted from equation 2? That's the question. Just change it. There is only two equation. So now the same thing they are again asking in it. There is a first equation, there is second equation. Again, can you tell me the matrix here which is associated with this system? I think 2 minus 4 minus 1 and 5. This is a matrix associated with it. And if you want to write down argumented matrix also, that is 6 and that is 0. Right? Now what they are asking for? You want to kick out minus 1. If you want to kick out minus 1, what multiple should you choose from here so that you can kick out minus 1? That's the question. What should you subtract? You should subtract what? You need to add 1. If I will say in addition definition, you need to add 1. So what can I say? I can say you will subtract minus 1 by 2 times of row 1. Are you seeing that? Because if I will subtract minus 1 by 2 times of, it will become minus 1. And if I will subtract minus 1 and minus 1, it is 0. Right? So my multiplier is minus 1 by 2. Can I proceed it? So it's my first row will remain same. Here it will become 0. And what it will become? I'm doing the half of this. I'm subtracting half. I'm subtracting minus half. So if I will do the minus half times of this, it will become positive 2. It's obviously positive 2. And if it is a positive 2, I'm going to subtract positive 2. It will become 3 here. Am I right? Because minus 4 times of minus 1 by 2, it will become positive 2. And if I will subtract, it will be 3. And if I will subtract minus 1 by 2 times of this, it will become minus 3, and if I will subtract, it will become positive 3. Is it okay? That going to be my upper triangular matrix. And can you write down the system now? My system is 2x minus 4y is 6, and my second row suggesting 3y is 3. What's the value of y? Y value is 1. And what's the value of x? Value of x would be 2x minus 4 times of 1, 4. 2x is 10, x would be 5. My value of x is 5, my value of y is 1. My third question is also done. They are saying after this elimination step, solve the triangular system. That's all. Till here it's completed. Is it okay? Now same thing they are asking, if you will change your right hand side from 60 to minus 60. What's the meaning? Your destination was 60 initially. Now your destination is the mirror image of that. Now your destination is completely down. Same amount at down. What will be the new solution? Okay, So if you allow me, can I do this improvement in the same question? Now if it will change to minus 60, the minus will come here, minus will come here, and how it will change? I'm doing the minus 1 by 2 times of this. Now it will become positive 3, and if I'm subtracting down, it will become minus 3. Am I right? And if I will write on my new system, it will become 3y is equal to minus 3, y will become minus 1. Am I right? And how it will affect on first equation? 2x minus 4 times of minus 1, it will become now positive 4. Instead of negative 4, it will become positive 4 now. And if it will go there, 2x is equal to 6 minus 4, 2x is 2, x would be 1. That should be changed. Now my new solution would be 1 and minus 1. I will combine both vectors as 1 and minus 1 to reach on my down point. Is it okay? That's my question number 3. Is it okay? If there is any problem, just mention in the comment section. My calculation is very poor, but if all calculation is right, that should be the answer. Okay. Now let's come on the question number 4. Okay. The question number 4 is saying what multiple L of equation 1 should be subtracted from equation 2? Okay. And they are even saying that the first A should not be 0, because if it will be 0, then Gauss elimination will fail. It will fail temporarily, but it will fail. And I don't want to assume that A would be non-zero. Okay. So can you write down a matrix again? The matrix which is associated with this is A, B, C and D. And what's the Gauss elimination is doing? I want to kick out this C. How can I kick out this C? To whom I should multiply here? What multiplier should I choose so that I can kick out this C? Can you tell me the multiplier? I want to, what should I subtract here so that it will become 0? Obviously C. So to whom I should multiply A so that it will create C here? C by A. So what would be my multiplier? C by A. It will become 0. My multiplier is C by A, right? And that would be D minus what? I'm doing the multiplication, I'm subtracting C by A times of row 1. So what will come here? BC minus A. And that would be my matrix, right? So what multiple L? So L would be C by A. Is it okay? Okay, the first part of the question is done. Now they are saying elimination produce what formula for the second pivot? My first pivot is A, and what is my second pivot? My second pivot is D minus BC over A, right? If you want to take the LCM, or if you just want to simplify the two fraction, I can say AD minus BC over A. That is my second pivot, right? Okay, now they are asking what is Y. They want to solve it. Can you help me to solve it? Yeah. So now can you write down this system of equation again for me? If you will see the second row, it's suggesting me to write down what? AD minus BC upon A times of Y is okay. I didn't choose my right hand side. Let me choose my right hand side also, then it would be easy. Here the right hand side will not change, it will remain F. And what it will become? G minus what? C by A times of F. Z minus C by A times of F. Am I right? The elimination is going to be happen at right side also. So what would be this? AD minus BC over A would be what? Can I solve it and can I say it's a GA minus CF over A? Yes, what do you say? Can I cancel A and A? So what's the value of Y? The value of Y is GA minus CF upon AD minus BC. That's the value of Y. Is it okay? These all are looking complicated, but that's all the answer. They're asking for the formula Y. The formula Y would be GA just minus CF. Whatever the values these are, you just do it and you will get back with the answer. Okay. And what they're asking at last? They're asking if the second pivot is missing when AD and BC is equal. When the second pivot would be missing? When this second pivot would be 0. And what is my second pivot? The second pivot is AD minus BC over A. Can you tell me when it would be 0? It would be 0. I can cross multiply A because A is already non-zero. The first pivot is non-zero. They are already defining it. So I can cross multiply. So when it would, the second pivot would be 0, when AD minus BC would be 0, when AD and BC would be equal. And that's they are asking for. The second pivot would be 0 when AD and BC would be equal. The question number 4 is also done. Is it okay? That's all. Okay, my question number 4 also done. Right? Okay. Now let's go on the question number 5. In the question number 5, they are saying choose a right hand side which give no solution and another right hand side which can give infinite many solution. That's what they are asking for. My first equation is 3x plus 2y is 10. My second equation is 3x plus 2y is 10. And my second equation is 6x plus 4y is what? What should I add up here so that it will give no solution? And what should I add up here so that it will give infinite many solution? Let's assume the column picture here. Are you seeing that? Let's assume the column picture. My first vector is 3 and 6. My second vector is 2 and 4. And I want to combine those two vectors in a right amount so that I will reach on 10 or what? You need to fill this blank. Now you need to tell me what should I fill up here so that you will get a valid solution or you will able to reach it. Once you will see these vectors, you will see something interesting. 3, 6, 2, 4. Are you seeing that both vectors are present in a same direction? 3, 6 would be somewhere here. This is my first vector 3, 6. And what is my second vector? 2, 4, which is also here. Both vectors are in a same direction. If I want to add them in a right amount, where I can reach? I can reach on all point which lies at a same direction, right? If you will ask me to reach here, if first point is 10, what should be this point? What should be the y? If you will see that the ratio is always 1 by 2. If first point is 10, I think if this point lies on this line, I can say this point would be 20. What do you say? Can I say? So I think if I will fix up this place as a 20, I can reach on it. Right? Is it clear? So if I select this point 20, there is a solution. But what happen if I will select any point other than 20? It would be somewhere here. But then can I reach them? I cannot, because are you seeing that the both vectors are present in a same line? So if I will take any combination, I can reach on all the point which lies in the direction of this line. But I cannot reach anywhere beyond this line. So if you will choose any point other than 20, if you will choose a point other than 20, then the equation doesn't have any solution. Right? If you will choose 20, the equation has solution and even it has infinite many solution. But if you will choose a point other than 20, there is no solution. Is the question number 5 is clear? Okay. Now let's come on the question number 6. Okay, I hope I am not fast. In the question number 6, again they are giving you the two equation and they are asking for choose the coefficient of b so that the system will become singular. Okay, so again I have a matrix which associated here is 2, 4, b and 8. Am I right? And according to Gauss elimination, I want to kick out this 4. What multiplier should I choose of row 1 which can kick out this 4? 2 obviously. So can I go? If I will choose the multiplier 2, if I will multiply 2 times of row 1 and going to subtract with row 2, it will become 0. And what it will become? It will become 8 minus what? 8 minus 2b. Is it? They're asking for when the system would be singular. When, according to Gauss, when the system will break, when the elimination will break, when my second pivot will become 0. That's the meaning. So when 8 minus 2b would be 0, when 2b would be 8 and b would be 4. If this b would be 4, then the second pivot will become 0, which is permanent breakdown, and the system will become singular. Am I right? Okay, or I can say the determinant will become 0, because if this would be 0, your determinant would be 0 and system will become singular, right? So that's what they're asking for. What value should I choose here, or what coefficient of y should I choose here so that system will become singular? So I think 2x plus 4y is 16. If I will take this, then this is a singular system whose determinant is 0, and in Gauss elimination it would be break. Am I right? That's all. Okay, now let's come on the next question. Come on the question number 7. In the question number 7, they are saying for which number A does elimination break down? Okay, what should you choose here so that elimination will break down? And they are asking for permanent breakdown. Okay, just before permanent, can you tell me when it will break down temporary? When A would be 0. If A would be 0, I can say your matrix would be here 0, 3, 4 and 6. And minus 3, 6. That would be your argument matrix. But do you know that you cannot start the Gauss elimination here because your first pivot is 0. But then Gauss suggested us that if the pivot is 0, then you can exchange the row for starting the elimination. Am I right? So can I exchange the row? So it would be 4. I'm writing my second row first and first row at last. Are you seeing that? Okay, I did anything wrong. It's if A would be 0, I can write down like that. And now are you seeing that if A would be 0, I am getting a temporary breakdown. If you will choose A as a 0, I am getting a temporary breakdown. Is it okay for you? But they're asking for when I will get a permanent breakdown. When I will get a permanent breakdown. Okay. So according to you, when I will get permanent. Okay, let me write down my matrix again back. Okay, they're asking for find a solution also. Solving x and y for second breakdown for a row exchange. Okay, if it is a temporary breakdown, can I solve it first? Then I will come on permanent breakdown. This is my upper triangular matrix. If you will write down the system, it is 4x plus 6y is 6 according to first equation, and 3y is minus 3 according to second row. So what is the value of y? Minus 1. And if you will put y is minus 1 here, my first equation will become 4x minus 6y is 6. 4x is equal to 12. I think x would be 3. That's my solution if it is a temporary breakdown. Now can I come on permanent breakdown? Yes. When it would be a permanent breakdown. So let me write down. My system was A4. This value I want to select so that it will become a permanent breakdown. And that is 3, 6. So if my first pivot would be 0, it would be a temporary breakdown. But this will be 0. If my second pivot will become 0, then it would be a permanent breakdown because then I cannot shuffle back. When it will become 0, see what is my first step. My first step is I want to eliminate this. I need to choose a right multiplier here so that I can eliminate this. But now I want a permanent breakdown condition, means I want to eliminate this in such a way such that it will create 0 as a second pivot. Here is a 6. What should I multiply in the first row so that this becomes 0? My 6 becomes 0. What should I multiply? What multiplier should I choose? 2, right? If I will multiply 2 times the first row, this will become 0. So what should be A here? I think I need to choose the number here so that when I will do the 2 times of this number, and if I will subtract from A, then it should be 0. What should be the multiplier? A should be 2, right? You can check it out. If I will fill up a as a 2, 3, 4, 6, then if you will choose 2 as a multiplier, this will become 0, which is not a harm, but this will also become 0 and it would become a permanent breakdown. Your second pivot becomes 0 and it becomes a singular case, right? That's the thing. I think if you are talking about a permanent breakdown, I should choose A as 2. Is it okay, the seventh question? Okay. Now come on the eighth question. In the eighth question, for which three numbers k does elimination break? They're asking for three values for which the elimination breakdown will happen. That's what they're asking for. And which is fixed by row exchange and which cannot be fixed up by row exchange. Okay, so the first thing is you can directly take k is equal to 0. If you will take k is equal to 0, your first pivot will become 0 and you cannot carry forward. But that is the temporary breakdown, I can say, right? Because that could be fixed up by the row exchange. So if you will directly choose k is equal to 0, it would be a temporary breakdown, right? And if it will temporary breakdown, which can be fixed up by the row exchange. Okay, now tell me what could be the permanent breakdown here. So can you help me to write down the matrix? It's a k, it's a 3, it's a 3, it's a k. That's all. Now, when it would be a permanent breakdown? When your this entry would be I can say would become 0. If your second pivot will become 0. Okay, I think if you will choose first pivot as a 0, then you can exchange it and I think it could be solved. But if the second pivot will become 0 in any case, then it would be a permanent breakdown. So what should I choose here so that it will become a permanent breakdown? Not 0, because if you will choose 0 as 1, then if I will choose 0, let's say 0, 3, 3, 0, it seems like a breakdown, but once you will exchange the rows, it will become 3, 0, 0, 3, and pivots are good here, determinant is 9, non-singular matrix which can be solved. It's a good point. So k, if k would be 0, it's a temporary breakdown. But what should I select here k so that it would become a permanent breakdown? How it will be 0? Very easy. I need to choose a number here so that when I will take the multiple from above, it will become 0 here. Can I choose k is equal to 3? If I will choose k is 3, then are you seeing what type of matrix it will become? 3, 3, 3 and 3. Now are you seeing that what will happen? If you, what multiplier should you choose here? If you will choose 1 as a minus 1 as a multiplier, and if you will subtract them, this will become 0, but with together this will also become 0 and it will be a permanent breakdown. Can you think about any other point? This will k is equal to 3 will create a permanent breakdown. Am I right? Okay. Now can you tell me any other point which can create a permanent breakdown? Think about this and it would be usual because whatever thing you are going to choose here, the same thing will come here. Can I take minus 3 if you allow me? Because if I will take minus 3, then again my matrix would be minus 3, 3, 3, minus 3. And now you need to subtract 1 times of another one. You need to subtract, oh no, I can say minus 1 times of first one. If you will choose a minus 1 times of plus 1 and you will subtract it, it will become 0 here. And what this minus 1 times of this will also become 0. So it's again a breakdown. So I think if k would be minus 3, still it would be a permanent breakdown. Am I right? Is it okay? So I got the 3 point where some temporary breakdown is going to be happen and the permanent breakdown is going to be happen. Is it right? Okay. Now I think in each case is the number of solution is 0 or 1 or infinite. Okay. If it is a permanent breakdown, I cannot think about the solution. It's okay, I can think about it. The right hand side is 6 and minus 6. I will go one by one in all case. If I will talk about my first case, the temporary breakdown, I got the point, I got the upper triangular matrix 3 0 0 3. And what is my argumented matrix? It's a 6 here, and what should be here? I'm taking 0. If I'm taking 0, I'm doing the row exchange. Okay, minus 6 would be here and 6 would be here. If I will solve it, what is the solution? How many solutions they have? If you will solve it here, y value is 2. If you will solve it here, what's the x value? 3x is minus 6. X value is minus 2. Are you seeing that? This is only the solution. If I will say that 3y should be 6, y should be 2, and if you will put above, I think this is only one solution in case of temporary breakdown. Now can you tell me in case of permanent breakdown? This is my one of the permanent breakdown where I subtract both of them in a same way. So if I will subtract them, the argumented matrix, okay, let me write down again. In case of k is equal to 3, my upper triangular matrix is 3 3 0 0. And what's here? How I'm subtracting them? I'm subtracting in the same way. It's a 3, it's a 3. I choose everything 3 and 3. So if I want to, what multiply should I choose so that it will eliminate this? I can see 1 times of that, right? So it's I think 6 and minus 6. If I will directly subtract them, it will create 6 and it will create 0 here. What do you say? Are you seeing the system? My system is right. Second equation is not suggesting anything, and first equation suggesting 3x plus 3y is 6. How many solution you can give for this equation? Infinite many. So in this condition, there would be infinite many solution, right? It's just a linear equation, straight line, all the or I can say x plus y is 2. You know how it would be line. All numbers whose addition is 2 would be the solution for this system of equation. There would be infinite many solutions, right? Similarly, you can do the third one, and I think you can do by your own. If it would be minus 3, that is my system of equation, that is permanent breakdown again. If it is minus 3, I am getting the equation minus 3, 3, minus 3, and this. My argumented matrix is 6 and minus 6, but here how I am subtracting? I am subtracting both. Okay, so it's a 6 minus 6, it will create 6 here and it will create 0 here. If you will follow the same thing at right hand side, again there would be infinite many solutions. Is it okay? The thing is, again, if it is for k is equal to minus 3, the solution would be infinite many, right? So that's all. Okay, so that's it, that proof my done. They're asking in each case either the solution would be 0 or the 1 or the infinite. I done this. Okay, now can I come on the last question of today, of this of at least for today, then I will come tomorrow back. In the last question they're asking for what test of b1 and b2 decide whether the two equation allow a solution. Okay, can you help me to write down the system of the matrix or coefficient matrix 3 6 minus 2 minus 4, and this is b1 b2, right? Now can you tell me, when you are seeing these vectors, if you will see in a column picture, my first vector is 3 6, my second vector is minus 2 minus 4, and I want to combine them in a right way and I want to reach on b1 b2. But are you seeing that again the both vectors lies on a same line? 3 6 minus 2 minus 4, they lies on a same line. When I can reach on a point, what type of points I can reach which lies on the same line, right? Are you seeing that? Because if you are taking the linear combination of these two vector which lies on the same line, all the linear combination would also be lies in a same line. So if this will also on a same line, then I can do the right combination and I can reach there. And when there would be a right, when this vector will also be lies on the same line, when the b1 over b2, the ratio of this will also be same as the ratio of this, or I can say when the ratio would be 1 by 2, right? Then this will also will lie on the same line, the slope will remain same, and I can reach. When I cannot reach, when b1, so I can say when b1 over b2 is equal to 1 by 2, the solution exists, right? And when I cannot reach, when b1 by b2 will not equal to 1 by 2, then I can say no solution exists. Is it okay? That's all. Okay. So these are the first 9 questions which I solved. Tomorrow we will meet again and we will solve the more question of Gauss elimination. Tomorrow I will concentrate on 3 cross 3 matrix at a time, and all the question which I'm going to solve tomorrow, that would based on 3 cross 3 matrix. These are the first 9 questions which I solved. I hope you enjoyed these lectures. But again, I'm saying it will be too much boring if you will just listen this lecture. You need to open the pen and you need to start solve by your own. If you stuck somewhere, then take the help of this lecture. But for now, for today, that's all. Thank you so much. We will meet tomorrow again back. Have a nice day.